Good day. This presentation is mainly deals with the sequencing problem which follows processing n jobs through 5 machines. The problem utilized for understanding the processing n jobs through 5 machine is find an optimal sequence for the following sequencing problem of 4 jobs through 5 machines. The 4 jobs are given first column 1, 2, 3, 4 and 5 machines are given in first row which is machine A, machine B, machine C, machine D and machine E. Every machine consumes their own processing time so that the numerical value given for processing time with the every machines of particular job. Finally, the question is determine the sequence for the 4 jobs that will minimize elapsed time. So, the conditions utilized for solving the problem is the first rule. The necessary conditions to be satisfied is either minimum of AI should be greater than or equal to maximum of B, C and machine D, or otherwise minimum of EI should be greater than or equal to maximum of machine B, machine C and machine D. If problem satisfied any one of above conditions, 5 machine problem is converted into 2 machine problem. How? Let's see. Xi is equal to AI Bi plus Ci plus Di. Likewise, I utilize formula. I convert the 4 machine into single column, and then I found another machine which is called as y is equal to b plus c plus d plus e. Likewise, I have to have utilized the formula for converting 5 machine problem into 2 machine problem. For this evaluation, I have to have identify minimum AI value from the available table. Here you see 7, 6, 5 and 8 available. From this, the minimum value is 5. So that I wrote like minimum of AI is equal to 5. After that, the next condition, the right hand side of the condition is maximum of B, C and D. For the reason, I have to have identify maximum of BI, maximum of CI and maximum of DI. So I have to compare the values that are available with the machine B column 5, 6, 4, 3. From this 6 is the maximum and the maximum C value from the machine C column in that 2, 4, 5, 3 available. From this maximum is 5 and then maximum D. In machine D column there is 3, 5, 6, 2 are available. From these 6 is the maximum, so that I wrote like maximum D is equal to 6. And then finally the second condition, the minimum E should be greater than or equal to maximum of BCT. For the reason, I have to identify minimum E value. Here you see 9, 10, 8, 6 are available. From this, the minimum EI value is 6. Likewise, I wrote after that I have to have examined the condition. Minimum of A is equal to 5, but the maximum of B, C, D are 6, 5, 6. So this condition is slightly satisfied, equal to is available. For the reason, I have to go for whether the maximum minimum value is available with this equation or not. Likewise, I want to check for the reason minimum of E is equal to 6 and this also 6 comma 5 comma 6. Here also the condition equal, but which is not greater than, but it is lying on equal, so that I have to have go for convert the 5 machine problem to 2 machine problem with the equations as like x is equal to a plus b plus c plus d. Likewise, I can convert the processing time. Here you see 7 with the machine A, 5 with the machine B, 2 with the machine C and 3 with the machine D. If I add both the things, 7 plus 5, 12, 12 plus 2, 14, 14 plus 3, 17. Likewise, I got after that yi is equal to b plus c plus d plus e. Here you see 5 plus 2 plus 3 plus 9. I may got 5 plus 2 7, 7 plus 3 10, 10 plus 9 19. Likewise, I have to have convert other rows which are job 2, job 3, job 4. I identify the newer processing time values and tabulated with the five machine problem it into two machine problem. After that, as usual, I have to identify the minimum value. The overall table, the minimum value is 14, but it lying on Y machine, which is second machine, and the job 4, so that I can allocate the job 4 from right hand side, because which is lying on second machine, so that I have to have allocate on right hand side. After that, I compare other values. I delete the fourth row. The other three rows I compared 17, 19, 21, 25, 20 and 23 are available. From this, 17 is the next minimum value. This processing time is available with the X machine with the job number 1, so that I can assign this one it into left hand side from X machine. Okay, after that I delete this row also. I compare four values which are 21, 25, 20, 23, which is each other. From this, 20 is the minimum value. The minimum value is available with the X machine with the three jobs, so that I can assign the third job from right hand side, so which consumes or occupies in second row. After that, the balance is 2. Second job I allocate with the bending row. Okay, so that I can get the sequence as like 1 3 2 4. So I retabulate with the 1 3 2 4, and I can assign the processing time that is available with the problem. So 1 7 5 2 3 9, and the third 5 4 5 6 8 likewise available. So here you see the third 5 4 5 6 8 likewise I reallocate or rearrange the table with respect to the identified sequence, which are 1 3 2 4. After that, as usual, the machine A, initially the input is 0 time. After that, I can add the processing time of job 1 with the machine A is 7. 0 plus 7 is equal to 7. After completing the job 1 with the machine A, the job 1 enters into the machine B with the initial processing time of 7. After that, in machine B, the job 1 processing time is 5, so that 7 plus 5 12. After that, the job enters into the machine C with the processing time, initial processing time 12. After that, it consumes 2 hours 2 minutes in machine C, so that 12 plus 2 is equal to 14. And then machine D, there is 14 is the entering time. After that, the processing time is 3, so that 14 plus 3 is equal to 17. And then machine E, which consumes 9 hours, but the initial processing time is 17, so that 17 plus 9 is equal to 26. Likewise, I got the value for first job. After that, I can load the third job with the machine A. When I can load the third job with the machine A after completing the job 1, only I can load the machine 3 with the machine A. So, job 1 consumes 7 hours with the machine A. After completing the 7 hours only I can load the job in machine A. Okay, so that the three job loaded at the 7th processing time at the machine A initial time. After that, I can the processing time of job 3 with the machine A is 5. So 7 plus 5 is equal to 12. After that, I compare the 12 with the machine B output, which is 12. Both are equal, so that I can enter here 12. The processing time with the machine B of job 3 is 4. 12 plus 4 16. Now again I compare the output time of machine B and the output time of machine C. Which one is maximum? 16 is maximum, so that the initial processing time with the machine C is 16. After that, I can add the machine C processing time for job 3 is 5. 16 plus 5 21. I compare again 21 with the 17. The 21 is the maximum, so that I can enter here 21. Now the processing time with the machine D of job 3 is 6, so I can add 21 plus 6 is equal to 27. Now again I can compare 26 with the machine E output of job 1, which one is maximum? 27 is the maximum, so that I can load the job 3 after 27 hours only in the machine E. So the machine E started for job 3 is 27 minute here, which consumes 8 minutes, so that 27 plus 8 I got 35. After that, the job 2 can be loaded on machine A. When I can load, after completing the job 3 only I can load. So 12 is the initial processing time for job 2 with the machine A. So 12 After that, I can examine the processing time from the initial table, which is 6. So that 12 plus 6, 18. Now again I compare 12 and 16. 12, 18 is the maximum. So that machine B entering time is 18. After that, how much of processing time it consumes? 6 hours. 18 plus 6, 24. Again I compare 24 and 21. 24 is the maximum, so that input value for machine C is 24 minutes. And then I have compared the processing time with the machine C, which is 4. So that 24 plus 4 is equal to 28. Now I again compare 28 with the 27. The maximum value is 28, so that I enter here a 28. After I compare the processing time with the initial table, which is 5, 28 plus 5 is equal to 33. After that, I compare 33 with 35. 35 is the maximum value, so that 35 I entered for input time of job 2 with the machine E, 35. After that, how much of processing time which consumes the machine job 2 with the machine E? 10 hours, I mean 10 minutes. So that 35 plus 10, 45. Likewise I got for job 2. After that, the job 4 enters as like our sequencing problem, so that machine A input time is started with the 18 minutes. After that, how much of processing time? 8. 18 plus 8, 26. I compare 26 and 24. 26 is the maximum, which means the job 4 completed 26 minutes only. I can load the job to machine B. I can't load at 24 minutes because the job 4 is running on machine A, so that machine B waiting for job 4. After that, it consumes 3 hours, so that 26 plus 3 is equal to 29. Again I compare 29 and 28. The maximum time is 29, so I enter here 29. The processing time as usual 3 available. 29 plus 3, 32. I now again I compare 32 with 33. 33 is the maximum, so that here I wrote like 33. The processing time of job 4 with the machine D is 2. 33 plus 2, 35. Final, the job 4 running on machine E is 6. Before that, I have to compare 35 minutes with the 45 minutes. 45 minutes is the maximum, so that the job 4 enters machine E with the 45 minutes. Now finally the processing time of job 4 is 6 minutes, so that 45 plus 6, 51. Likewise, I can tabulate and identify the processing time of every jobs with the every machines. After that, I can identify the processing time, total elapsed time, which is 51 hours. From the sequencing table, I can get 51 hours. And then idle time for machine A. Machine A continuously run, there is no stoppage available, so that the final processing time 51 minus 26 is 25 hours is the ideal time for machine A. After that, the ideal time for machine B. Initially, it waiting for job 1 up to 7 minutes, so that initially the machine B consumes 7 minutes as a idle time. After that, the 12 is available, there is no idle time. After that, machine B stopped with the job 3 as 16, but started for job 2 is 18, so that here 2 minutes lagging. So the machine B stopped up to 18 minutes, so that here 2 minutes available, so that 7 plus 2. After that, I compare the job 2 available with the machine B 24 minutes, but the job 4 enters the machine B at 26 minutes only, so that machine B is waiting for job 4 up to 2 minutes, because I can get 26 minus 24, so I can get 2. After that, the job 4 in machine B completed 29 minutes, but after that job 4 moves with the machine E. So up to that time, machine B stopped the machine B as idle. So 51 minus 29, I can get 33 hours. 7 plus 2 plus 2 plus 51 minus 29, I can get 33 hours. Similar to same, I can identify the idle time for machine C and idle time for machine D and idle time for machine E. Here I wrongly enter, which is E. Okay, idle time for machine E, which is the initial time is 17, and in between there is 27 for job 3 is the initial processing time, and this 26 is the job 1 output time from the machine E, so that here 1 minute is lagging available, so that idle time of our machine E is 17 plus 1 is equal to 19 hours. Likewise I can get, which is the procedure for identifying the total elapsed time and the idle time with the Johnson's algorithm for processing n jobs through 5 machines. If you are having any doubts, you may ask me through comment box.